everyone. I am Sudip Kesh, Chief Innovation Officer at S&P Global Ratings, and welcome to Artificial Intelligence Insights, where today I'm very, very thrilled because the topic that we're going to discuss today is all about AI agents, and you may have seen things called agentic AI, so we're going to be talking about that. And even more than that, I am joined with some of the smartest people I really know, right? So I want to make sure that the time is sort of allocated to these gentlemen. Their great remarks. So let's get started. So let me introduce our folks, maybe just in alphabetical order by name. So Mike Carroll joins us from Georgia Pacific. Mike, do you want to introduce yourself?
Yeah, so I've been at Georgia Pacific for about 15 years. I run innovation for the operations organization, and we've been involved in this for quite a long time. We have a lot of headwinds we're trying to get over, and I'm looking forward to the conversation.
Thanks, Mike. And next up we have Chinadu. Chinadu, he was the founder of Hopstop, and he's done a lot of really interesting things throughout his career. Chinadu, do you want to introduce yourself as well?
Sure. So thanks, Sudeep, for inviting me as well. So I'm Chinedu Echero. I am the founder of the Beloved Ecosystem, which is a startup builder for distressed communities using agentic AI.
Excellent. Thank you, Chinadu. And last and not least, we have author, strategist, brilliant mind, Brian. Brian, do you want to introduce yourself?
Sure, I'm happy to. Thank you so much for having me. Brian Evergreen. I am the author of Autonomous Transformation, and I'm the founder of the Future Solving Company, where I help organizations position themselves for the future in the era of AI.
Excellent. And Brian, let's get started with you. So I have a question on behalf of everyone. So let's just frame the conversation. What are AI agents in the first place? And roughly, can you just explain, just from your perspective, how do they work?
Great question. So AI agents is a term that's become increasingly popular over this last summer. Something that I was working on at Microsoft well before it was popular. And I think that there's a couple definitions out there, and I want to sort of lay out a few of them and then give my perspective. So one definition is agentic AI is any form of a system that does has agent-like interactions with the user. And that's one definition is, this is agentic because I can tell it to do something, which is what it would be like if I were working with an actual agent. So that's one type of definition. Another type of definition is sort of the using multiple language models, more the natural language processing and NLP agents, which is saying I'm going to give this language model a prompt, and then whatever the output is from that, it's going to pass over to this other prompt, the output from that, and it's going to go through a string of different prompts to eventually give me some kind of hopefully non-hallucinatory useful output. And that's being called AI, NLP agents. Then there's agents in gaming, which I think is the closest to real world agents of these examples I'm giving so far, which is, okay, we're going to put this agent we're going to put a system into an actual game, and we're going to give it, reward functions, and we're going to just let it learn through the process of experimentation how to play this game and how to interact with all the different aspects of the game. And then lastly, I think there's another form of agents, which is where you are essentially creating a system. And this is the one that, Mike, I'm sure I'm excited to hear your thoughts on. Creating a system that can actually reason and make decisions independent of any human intervention, which to me is the most accurate definition. So calling all those other things, I think we need better new terms for some of the things that are not actual agents, where I can say, I'm going to, as a human and as a user, I'm going to give this instruction or request to an agent the way that I think we need to define systems by what they do. So an agent, if you think about like in the intelligence community, an agent is someone that you assign to go do something, versus a source is something that someone you get information from, and a researcher is someone who researches for you. And those are all valuable, but they're not the same as agents. So that's the first sort of feedback and definitions I give there. I hope that's helpful.
Yeah, I don't know. It is really helpful, and I guess it's probably important just for our audience to recognize as well that as humans, we are single individuals, right? But we actually, once you convert that into sort of this agentic AI, you could actually be thousands of different agents in terms of all of the different activities and work streams and agency that you have in certain capacities that could transfer. So let's pull on that thread. Mike, do you want to, with that last bit that Brian had mentioned, do you want to respond to that in terms of some of your experience on agentic AI?
Yeah, so let's just explore this for a second, because my background also goes into psychology, because I think Brian's really poking at something that in our lives today, we actually create agency for ourselves by taking the things that we know are true, by taking the things that we make true, right, the actions, and we take that, we apply an action and create agency in shape of an outcome that we desire to happen. And we live in that world today, and there are applications that we use today to do that for us, to shape greater outcomes for ourselves. And one of those is called Waze. So if you live where I live, near Atlanta, and you're in traffic in Atlanta, right? You actually depend on Waze or Google Maps if you choose to use that you use that to do the navigational calculus for you, which is quite difficult. It actually offloads that cognitive load from you, so you focus just on having to plan and orchestrate getting your vehicle in the right place to execute the turn when it tells you you need to execute it, get in the right lane, all that stuff. It's creating agency for you by shaping a better outcome for you by handling the complexity of navigation on your behalf. So it is an agent that is helping you create greater agency. And I think Brian's absolutely right. As we become more familiar with these things, we will begin to give them better context in our world, because today we really don't quite know what they are. We don't quite know how to use them or what to call them. And I think we're only at the beginning of this. Brian?
Yeah, I agree. We are only at the beginning, and I think that the future of using agents will be, I think there's playing 2D chess is trying to create agents that can just do everything. I think I can understand why that's appealing from a user perspective, thinking from a customer obsession perspective. But I think 3D chess is you creating agents that essentially will circumvent the current version of the internet. We're trying to right now create agents that will navigate the current version of the internet and learn what a hamburger menu is and be able to figure out, okay, if I click here and click there, some bad examples of RPA that we've seen with that as well. Not to name, names of any specific, attempts to create this useful things in that space. But I think the future will be where we have agent to agent, an entire agentic marketplace of agents that are task specific. So you're not going to have an Amazon agent that the one agent can handle every single type of task that somebody could want from Amazon as a retailer. You're going to have specific agents that are specialized, just like people are, on specific tasks and specific functions, and that then those agents in that agentic marketplace can interact in between each other and create new types of value that don't exist today, because they can blur organizational boundary lines. Like today, if I, in terms of a value chain, if I have a deal on the line, I work for a CPG company and I have a deal on the line, I'm a salesperson, and I want to close this, but I don't know if I check in our system, I can't tell if we're going to be able to make that product to spec, and maybe I can call and check, or I don't know if we'll get the supply that we need up, from one of our suppliers. But in this agentic, and it'd be too time intensive for me to call every single person that I would need to call to be able to check all of that. But in this agentic future, I can just submit, hey, this is the client need. Can we, as a value system, can we meet that? And the agents representing folks within other silos in my organization, without me having to message them on Teams or Slack, can reply in milliseconds, as can agents representing my suppliers. And I can actually conduct deals in a matter of milliseconds that involve multiple organizations making commitments based off of their availability and their their inventory in a paradigm that just doesn't exist today.
Yeah. Hey, Brian, let me pull on that, and Chinadu, I'd love for you to chime in here. So, sort of connecting with this transportation thing, and for everyone's benefit on because I know these gentlemen. Brian is a world-class chess master. So when he's talking about gaming simulation, all of the different permutations that go into chess are very much sort of reminiscent of what goes through human psychology, industrial psychology, all of these different probabilities, all of these different neurological channels of decision making, and so on. Similarly, with the Waze example that Mike had brought up, actually kind of reminds me of Chinadu, your old hat with Hopstop, and for everyone's benefit as well. If you're using an Apple phone or Apple device, when you go into Maps and then you put in your transit directions, you have Chinadu to thank for that. So he's the brains behind that operation. And presumably, I think where the connection is that you have to be aware of where you are today in order, let's say it's transit directions, right? You have to know where you are, you need to know what are the options available, you need to know where you're going, all of these other stuff. And that's not agentic AI, right? It's machine learning combined with a bunch of other sort of technologies kind of stacked together. But if you take this sort of, I don't know, modality is not really the right word, but it's just like if you take this sort of concept and framing as applies to transportation and then apply it to sort of social systems and even eliminating potentially, intergenerational poverty with a beloved ecosystem, you could really understand like sort of the power of the interconnectivity between where you are, where you need to be, and what are the different sort of operations in between. So that was a super loaded question, but Chinadu, do you want to just kind of just enlighten us with your thinking?
Yeah, so I 100% agree with what Brian and Mike have laid out. In order to add to the contribution, to the conversation, I would also say, Sudeep, just as you point out, so what Hopstop used to do is you typed in where you are at point A and where you'd like to be in point B, and then the algorithm will figure out the shortest path, so to speak, to get to point A, from point A to B. But that's all our journeys as customers, as people, as sentient human beings. We always have a goal. We always have some sort of end point, right? So I think of agentic AI as always the maximal version of that, as some system that can figure out how to get from point A to point B. But unlike Hopstop, which still took a very complex problem and tried to make it simple, I think the future of wealth creation and the future of work is really let the AI systems figure out the best way to get to point B. So.
Yeah, and essentially it's bi-directional in terms of the learning. So it's not, I guess that's a key operative difference between agentic AI and some of the other, discriminative, machine learning algorithms and so on, is that we're not necessarily playing puppet master and saying, look, I'm going to call all the shots. I want you to optimize this problem that I've already defined. AI is able to then, agentic AI specifically, is able to more thoroughly understand sort of the problem and the related problems and start developing these sort of systems and systems of systems to help educate us. Is that fair, Chinadu?
Well, I'll make a more subtle distinction, so not to get too technical, but so existing AI systems try to optimize certain functions. So they typically try to optimize cost functions. But as a human being, as an agent, you're not just trying to optimize cost functions. And that distinction is the difference between the AI agent architectures that are coming up and the existing kind of architectures now. As a human being, you're not just trying to figure out the best cost. It's a much more complex optimization function that most human beings try to optimize.
All right. Mike, I'm looking at you. You're thinking about this all the time, not just in an industrial capacity, but also thinking about the interoperations of education systems and learning effectiveness, and quite some time, quite some other venues. Do you want to share some of your thoughts or some of your experience or research in that capacity?
I think the reason I like this forum is that all four of us, we don't know it all. Matter of fact, we know very little. And in this conversation, we're going to learn from each other. And most of this is just like the work with Greater Atlanta Christian, right? That we're doing, right? That I'm doing, is we start out saying, can we improve scores of students? And is that actually possible to do that with an AI tutor? And what would have to be true? And so you start asking these questions. What makes that true? What would have to be true? And there are some wonderfully powerful tools, and Brian knows all about them, and Chinadu knows about them, and Sudeep, you know about them because we talk about them. And you can actually take, and you can build today, you can take and build these wonderfully broad causal models and pile these causal models into Bayesian labs and develop a model of what makes that true out of all the published research from 2024 and before, and it'll build a causal model as to what makes all that stuff true. And it turns out that once you've built this AI agent, you start capturing data from it. What the causal model said, and what was really interesting, in the data suggested that if you're already getting A's, using an AI-based tutor uses Socratic methods. If you're getting A's, using it doesn't really make you get better A's. You still get A's. So whether you use it or not didn't really help. But if you weren't getting A's, or if you were getting C's and D's, it really helped. So think about that for a second. It really helped. There was a huge difference between the students that used it and the students that didn't. A big difference. That suggests that the way we measure things might need to be improved because we're only measuring grades, right, as represented in tests. And so then it also suggested that when we looked at it, that when we looked at how the kids were using the tool, it actually helped them weed out what the wrong answers were. So what the causal model said is the reason it works is because it helps people understand what wrong is more so than what right is. So Brian's really smiling, and I see him smiling. So understanding and learning is starting to say, do we really understand how this really works from a learning perspective that we've always been geared toward, are you getting the right answer? When are we actually, should we be geared at asking better questions so we understand where do we need to learn more so we know what wrong actually is, right? Or what better actually is. I don't even know how to think about it because it's really started to shape how do we actually go about learning in this new world where the difference between what we thought was true and what actually turns out to be true when you actually get in the heart of what the data says may not be the same thing.
Let's pull on that. So Brian, I'm going to give you a two-parter. First, I think if you can enlighten everyone with the concept around future solving and then going through this what needs to be true exercise to kind of make, a structural paradigm for enabling that clarity, I think that would be helpful. The other thing, you recently had written, I forgot where, and hopefully I'm not getting this like super wrong, but the difference between analysis and synthesis, and sort of connecting, what Mike was describing in terms of you take your hypothesis, what you think is true, and then you start looking at the data and then either validating or it might have some, changes in assumptions and so on. But also synthesis enables really the systems of systems thinking to say, okay, these are a lot of interoperable parts, and we may take it for granted, like Mike was saying, that some of these mechanisms that we've had for the last 50, 60 years may not actually work tomorrow because structurally there's a difference in how to sort of go about it. So do you mind starting us off? I don't think you don't have to bear the burden of landing that plane. But can you take us on both future solving and then this difference between analysis and synthesis?
Let's do it. Yeah, that sounds great. So future solving. So the problem with solving problems is one of the chapters I wrote about in autonomous transformation, which is that problem solving is the craft of getting rid of what you don't want. So if there's something that if there's a problem that you're facing, getting rid of it, now that problem has been solved. And what are you going to do? You're going to move on to the next problem, and you're going to incrementally improve, kind of in perpetuity. Future solving is the craft of getting what it is that you do want. So there's no guarantee by getting rid of what you don't want that you'll end up with what it is that you do want. But by future solving, if you start with the future that you do want and work backwards and say, what are the things that would have to be true for us to reach this future? And for each answer to that first question, you say, well, what would have to be true for that to be true? You end up back to what you mentioned, Sudeep, about my chess background. You end up with a decision tree that you can essentially work through in a focused line of investments from where you are to where you want to be. And in more cases than not, that as I've worked with organizations on this, in more cases than not, the problems that you would otherwise have solved end up dissolving instead of needing to be solved. Because you're moving to a new system anyway, or you're replacing your process anyway with a significantly better process. So you could have made it 2% more efficient by going and solving another one of those problems, but because you're replacing it with an entirely new process, now it's 20 times more efficient, right? Or whatever. And so that's the first, is future solving versus problem solving. And then in terms of analysis versus synthesis, we in the 1950s, when analysis and synthesis were codified from the systems thinking movement, analysis has continued to be, I think, because it's so basic to the way that we function as humans, that analysis is very easy for us to conceptualize and glom onto. But synthesis is equally as important, but I call it the lost art of synthesis, because it's mostly lost to time for the average organization. It's not held up. If you go on LinkedIn, people aren't listing synthesis right next to analysis. They're saying, I'm a highly analytical problem solver, right? And to me, that means I am an incremental improver. So you put me on something, I'll make it slightly better every time. And that's great. We absolutely need people with those skills. But we need to balance it, especially if we're talking about innovation and anything new, with future solving and with synthesis. So I'll give a quick definition. Is analysis is you gain knowledge of how something works by breaking it down into smaller parts. And so if you took a university and you said, well, let's talk about how this university is performing. Most people, if you say, well, how is a university performing? They go, well, how many departments does it have? How many tenured professors? How many research papers are being published by those professors? What's the size of endowment, and et cetera, right? That's analysis. You're breaking it down to its smaller pieces. You're analyzing, and you can even further break those down, and you're trying to understand all the smaller parts to then aggregate back into an understanding of the performance of the whole. But all that tells us, it gives us knowledge of how something works. But it doesn't tell us why it exists, or it doesn't give us understanding. For understanding, we need synthesis, which you take the same subject, in the case university and how it's performing, but instead of looking at it as a whole that you're going to break down into smaller pieces, you say, what bigger system is this thing a part of? So the university is a part of the education system. So then you can think, well, what does the education system exist to achieve? And therefore, how is a university performing toward that, what the bigger system needs of the university? And that's synthesis. So then you go to the broader system, and then you disaggregate your understanding of the broader system back down to the subject of your synthetic thinking, to be able to say, okay, this is performing this well or not, because the goal of the education system is to graduate students that are able to immediately add value in the workforce. It doesn't matter that we have this many tenured professors or this many research papers if we're not fulfilling what the education and what the actual workforce system needs from a university. And so that's kind of an example of analysis versus synthesis.
Excellent. Chinadu, can you help with this also? Because I was inspired, we had an event that Chinadu and I were speaking together. It's called Imagine AI at Cornell Tech University. And Chinadu was he was working on things that, personally, one of the first economically distressed communities is actually only 20 minutes from where I live. It's in Newark, New Jersey, right? And it's evidence that, very, very, close to me, the system is clearly not working in terms of economic inclusion and stuff like that. Chinadu, do you want to just pull on some of those? And if you want to nerd out on any of the physics behind it too, we're all in. So Chinadu, go ahead.
Sure. So, Brian, I like your synthesis and analysis distinction. But it really points to this question of what exactly are we trying to measure? What is it that we're trying to optimize? Right, so it's a simple question to ask, but it's really a hard question for us to answer, not just as systems designers, but as human beings, I mean, how many of us, like, what do I want out of life? Oh my God, that's a deep question, What do you want out of relationships? What I'm saying that part of why this agentic AI is so exciting and why it's so perilous is because it forces us to answer the question, what do we want? Where do we want to be? What's that function we're trying to optimize? So deep to the question of new work, right? So what is it that the system in new work is trying to optimize? What's point B? So I guess, so with this agentic view, we now, to Brian's point, like what is it that the systems that keeps that sustains salaries of $20,000 a year? What sort of destination is that system? So really, destinations become the highest point of leverage in this agentic AI world for us to be cognizant of these systems and really decouple the machine from the goal, right? As Brian pointed out, like it's one thing to look at new work and break it up into sections of people and move money around, but to Brian's point, what's the synthesis? What's the real? Where do the people who live in these communities fit in the broader narrative of economic or community development? So I think agentic AI lets us play in this fertile ground of possibilities of what could be instead of what the systems are currently designed for.
And I think one thing that, I get a question quite often, and I think we all, just not in just this room, but, as society, really think about, look, AI is really interesting and it's really cool. And most corporations and most, education systems and so on are really just kind of dabbling their toes, to Mike's earlier point. Like we know like this much about it. I think for the folks in this room, we're actively looking. That's what may sort of differentiate it, us is we're constantly just kind of looking and evaluating just what are those different opportunities, what are those different risks, what are the things that we're assuming, what are the things that those assumptions end up inhibiting in terms of our thinking, how do you unblock those, how do you unlock some of the potential, the possibilities. One specific thing that I think is in the front of everybody's mind who's involved in AI is that it consumes a lot of power. And I think one of the things that agentic AI helps with is because of both its operating efficiency and its nature and how it basically sort of breaks down a lot of these complex systems. It doesn't have to necessarily deal with the entire system at once. It ends up being more power efficient. And Mike, I think you probably have some direct experience on AI and power, but then also how agent-based paradigms can help.
I think, and Brian can pile in on this too, because when you look at what these AI agents really are going to become, they're going to become largely knowledge models, right? And so what a knowledge model actually is it's the harmonization of what you know to be true with the things that you make true, all combined into an optimization that looks at a stream of data. And as long as the data that passes by matches the knowledge model, you don't have to remember that. That's considerably different from a machine learning model that's really heavy and compute intensive. The only time you ever need to pass something across the network is if it's an exception. And then you need to do some processing on that exception relative to what makes that true, right, Brian? And so now you got a knowledge model on a sensor because it is so, the power it demands is so light, right? And so these things enable you to run knowledge models that actually look at the data, right, as their hypothesis to see if the hypothesis is true in the data. So you're doing real science on the sensors at the edge of the environment in real time, rather than having all the data piled at the edge. Brian, you want to jump in on that?
You know I do. So yes, I echo exactly what you said, Mike. Essentially, if you think, and I've been thinking for a while about how to explain this to people without the technical background. And I'll take this is my first tryout. You guys let me know what you think. Which is essentially that the way that we as humans want to learn an instrument. I see you have some guitars behind you, CD. And for me, piano was my instrument. The amount of time and energy it takes to learn a song, practicing it, over and over and over again. And then, but eventually you get into a point where it becomes muscle memory and you don't have to think anymore. And you can actually just emote and feel, right? But it doesn't take you don't have to relearn it every time you're playing. Now it's muscle memory. And you can sit down, you can just play it, right? And so that to me is an analogy for what Mike's describing, which is that if something trains in a compute intensive training in the cloud, but then if it's being structured in, I think the best possible way is it can then be flattened to a neural net that essentially you can export the skill, you can export the learning. When I see this, I do that. So you've taken, to your point, Mike, about experimentation, we're trying to create scientific laws where you make an observation, you immediately take an action, right? We don't need to experiment with gravity anymore. We already know what gravity does, right? And so the same thing with our business. If there's something where every single time I see this come through, I immediately take this action. Once it's been trained, and maybe it's used deep reinforcement learning to train in the cloud, and it's done 2 million simulations in order to really learn it. Now it can be, all the learning can be exported to like a couple megabytes, and it can be deployed, just like Mike said, at the edge, and on a data stream where you can also dump the data after it's been used. You could have the data streaming through. We have this obsession with storing all data because we're hoping that the data will be, data's the new gold. Store every bit of data that you could possibly have is what we're being told. But that's not true. Data it's a system of record of something that happened. The actual most valuable thing you have in your organization is expertise. So when you start by looking through your data to see how can I make this useful, you might find something, but you're definitely going to find something useful if you start with your experts. And then you might say, oh, this is a nugget of expertise that if we can find a way to translate that to machine language, would be the most valuable system we'd have in our whole organization. And once it's been translated, as that data is streaming through and the control action or the decision is being made, autonomously without humans intervening, we might not need to store that data, which also means less compute, less data storage, less costs, less emissions, etc.
You just store. What do you need to know? What do you need to do with it? That's it.
Yeah, just to add to that, again, Sudhir, I know you like nerdy bits, so I'll just inject. Yeah, so it points to a good distinction that I didn't have in my mind until a few years ago. I just maybe share it with you and maybe get what you guys think. So the question is, what is the distinction between data and information? Because that's really what we're talking about. And I think conflating those two is really why this question is so confusing for so many people. So to add clarity, let me just maybe share a few ideas. So data isn't information aren't like numbers in a spreadsheet, right? That's data. Information is what the data means. But that distinction is very important, right? For as we think about what AI is and what data is. Data you already know isn't information, as Brian talked about. So that's very important to know. So what information organizations seek shouldn't be data as well. It should be things that are meaningful to the objectives of the company and the hypothesis which they want to put to test, right? So it just allows you to think more clearly about what sort of information or what sort of data you should be collected.
Yeah, that reminds me of one of my I consider him to be a mentor, even though he passed away before I had the fortune of learning about his work. Dr. Russell Ackoff. Mike, and Mike and Sudeep, you both know about my passion for this expert and all that he was a professor at Wharton, one of the leaders in the systems thinking movement. He defined it as the DIKW pyramid. Data, information, knowledge, and wisdom. And so I think that relates to what you shared, Chinedu.
Yes, yeah, 100%. And for the physicist on the call, on the listening, you can think of like Wheeler, right, where you have this idea of it's from bits, where the things are made of information, and the question is what's the information that the things you're looking for are made of? That's the information you should be seeking.
Yeah, and it actually, I mean, the only bit I would add is really the irony of all of this is that it actually makes us much more human, right? We're able to better focus on the creativity and the relationships and all of the things that you can extrapolate. The thing that kind of comes to mind is in jazz circles, there's this book, it's called The Real Book, and it basically kind of has the chord structure of every sort of jazz standard and everything else. And the point is that if you're a learned jazz musician, then you could just basically, someone makes a request for a song, you just flip to the page, you know more or less the chord structure, and you just improvise.
Sets us free.
Yep.
When you're unburdened by complexity, the necessity to do that complexity, and when you apply the power that compute gives us to deal with that complexity that's burdened us today, I think it sets us free.
Exactly. Yeah, I talk about it as exploration to operations. Because if you think about, if we were today to discover something in the deep ocean, and it's a new substance we've never seen before, we would be exploring, right? The first thing we do is we would come up with language for what are we going to call this thing? And then we'd run a series of tests on, okay, how does it conduct electricity? How does it respond to heat? How does it, et cetera, et cetera. And then eventually we would gain, so it would be language, and then we would gain knowledge. And then eventually, once we knew, this does conduct electricity really well, I wonder how it would pair up against other things in chip making. I wonder how much more of it there is at the bottom of the ocean. I wonder what the ecological impacts would be if we started trying to, get some more of it. And then eventually we'd get to a point so from language to knowledge to expertise. And then at the very end of that, we'd be operationalizing. Once we figured out something we wanted to use it for, if we did, making that assumption, then we would have expertise and we'd operationalize it. And then at the very end of that operationalization, now we start having a data feed, right? And so that's, to me, I think to your point of the promise of what AI offers or it can offer us if we as people get to decide how we're going to use this stuff, right? AI is not coming for anyone's job. It's never not knocking on anyone's door saying, hey, I'd like this person's job. It's leaders that are making decisions of how they're going to implement and use AI. And so I think that if we make the right decisions, we can actually leverage AI for the operations side of work, so the humans can be freed up to do continuous and ongoing exploration. And there's a lot more we as a society, we talk about automating all jobs and living on a basic income, and not speaking to the political side of that, but just from a as motivation side as humans, I think we have a lot more work to do. We haven't solved cancer. We haven't we haven't cracked the nut on space exploration. We haven't even figured, at this point, we need to figure out how to right some of the wrongs that the digital transformation era have done on our youth, and figure out what does it mean to be human now, in this era today. What does connection mean? How do we form and maintain social bonds in this era? There's a lot of work for us to do, and so I think that when people get all excited about how AI is going to change everything and it's going to automate away everything, there's a big assumption there that we've already reached the finish line. Now we just got to automate and then go into a WALL-E-like state, being entertained and fed. And I don't know about all of you, but that doesn't resonate with me. I'm not interested in that future. And I think we get to choose which future we're going to create.
And that's the bit that I get in a lot of different circles is some confusion between artificial intelligence systems and automation systems are very, very different. And I think in terms of the knowledge that you were also sort of articulating, all three of you that you were articulating, it's you have these bits of sort of knowledge of the operations that are actually sort of cross domain that whether you're in art sciences or you're in social sciences or if you're manufacturing products or in service or organizations and so on, there's just a lot of stuff that we do that is very much the same. And it's like if you can actually have some extrapolation of some of the knowledge and best practices and things like that that actually go across different sort of verticals, that buys some headroom, which hopefully could buy some thinking space to actually start addressing, first defining all of these problems like what you mentioned, Brian. We need to do that. Like we need to basically, and it doesn't, it's
We've been here before.
Yeah.
So we've been here before. Unfortunately, it was on the backs of others, but the headroom was bought during the Renaissance on the backs of peasants. But the people that got the headroom were the people that were the lords, right? And so they got the benefit of either having to pay somebody to do the thinking for them or to do the thinking for themselves because they had this surrounding community to do the work for them that paid them to do that. And I think when you unleash entire communities, because you can now allow those folks to use AI to deal with complexity for them. Now you're talking about a scale that is just completely different. And I think that I think an entire planet of really smart people, and humans are really smart, right? And industrious, being applied to solving all these problems together is something we've never seen before.
Oh my God, Mike, thank you. Sadeep, this is great. This is I could see why you thought would be kindred spirits. And I think that's the wonderful opportunity Mike has just said, what agentic AI, what it can really do is distribute the intelligence needed for optimal agency in a way that we've never had before. We've had essentially cabals, small groups, very small members of society who are, just because of the nature of intelligence, control intelligent machines. And those intelligent machines have the ability to recruit economic wealth at exponential rates. So that is a system that is unsustainable, and I think we're laying it now. So Mike, I love the things you said because you laid it out very clearly. If we can distribute agentic AI on the individual level, on the human level, we can unlock agency that the world has never seen before.
Yep. So just for the benefit, I think all of us in this room can appreciate the need for downtime to be able to kind of think and kind of have our quiet space and so on. I want to leave that for our audience as well, to be able to kind of digest and process. One of the things that is really important to me on this podcast is really to be able to provide, this balanced view. So let's just do a quick round robin of, if we were just to sort of project what, our own sort of future, either 5 years from now, 10 years from now, with respect to agentic AI, what's one thing that you're excited about in terms of, a big opportunity here? And what's one thing you're a little bit unsure of, that whether that keeps you up at night or you think it's a managed risk? What's one thing that you're worried about? Brian, do you want to go first?
Sure. So one thing I'm excited about is the transforming of the way that we interact with, let's say, brands. That instead of the amount of manual work that we do when we want to, get groceries for a party that we're going to throw, or even just the amount of time we spend on screens to navigate the work that we have to do. So if I need to book a hotel for tonight because I'm headed to somewhere, I've got it. That's how many clicks is that? Even though Expedia's done a great job, it's an amazing application. The fact that I could instead say, I'm trying to stay, I'm going to this city tonight. Can you get me a hotel? And the hotels, the types of hotels I like to stay at, the price points that work for me. can you give me 3 options? And then, even just audibly saying, yep, here's this one and this one and this one. And I say, oh, that one sounds great, thanks. Boom, it's booked, right? I don't have to touch anything else. Same with calling an Uber, same with anything and everything, right? The amount of, to what we were just talking about, the amount of mental and just the workload of navigating our day-to-day lives and interacting with all the different things that we interact with in order to get toilet paper to our homes, from our dear friends at Georgia Pacific, to being able to get that just by speaking and saying, I need all the regular groceries I usually need, and to be able to dynamically build a cart. At that point, the choice is different, because it's truly like jobs to be done. For those familiar with that framework, I want the toilet paper, I want the paper towels, I want the fruit and veggies and the steak or whatever I normally order. I don't care who the retailer is that's actually fulfilling the order, and I might not care, unless I have a specific brand love, who the actual supplier underneath, behind the retailer is. I just want, the goods at the right quality and the right price and the right logistics. So that's something I'm excited for, and the way that will transform, because I feel like there's times where marketing fills this gap where we buy something because it's so well marketed, but the price to quality behind that suffers because the marketing's so good. And so if we move into a future where agents are buying for us and agents don't have emotional appeal to be marketed to, then there can be a reinvestment of some of those resources into better goods at a better price. So that's something I'm excited about. Something I'm worried about is as we, just like with the internet, now that we've put so many of our systems, critical systems, online, if there's an outage, there's ways that has broad sweeping effects. I think the same will be true with agents. If we've given agents control over our debits or credit cards, obviously we're going to set limits in place and things like that. But if we can if we end up in a future where there's drones flying all around us and we're driving in autonomous cars, the thing probably that keeps me up at night, after having ridden in my first Waymo ride, which was awesome, and I thought, wow, we should do this everywhere. And then I had this second thought, which was, but what if I was riding in a Waymo and someone could hack it, right? I think that there's a version of the future where hacking has even broader sweeping implications than it does today. And that's one of the, I don't know yet that that's a managed risk. I'm not speaking to Waymo specifically, but just in general, that's probably the area that I feel the most concern about is bad actors and the way that these tools can also be used as weapons.
Yeah, and I guess the intersection therein between bad actors and contagion and disparate systems, which is that's the counterpoint, right, to your opportunity. Like, once you have the systems in place, it enables the decision making. Once you have the system in place, it could be weaponized by bad actors. Excellent. Chinadu, do you want to go next? Just one thing that, an opportunity and a risk.
Sure. The funny thing is, it's the same thing, and I'll rip off of what Brian said. It's basically, once you can, so there's new math for agentic AI, and that new math for agentic AI could lead us to human prosperity that we've never had before. And the simple economic reason for that, because it allows us to organize ourselves better, like Mike and Brian have talked about. So if you can organize yourself, you can create wealth. So you can think of wealth as entropy reduction or the reduction of disorder in systems. So that's the technical reason why agentic AI can bring in human abundance. But it's also precisely the same reason why this agentic AI could lead to human destruction, is because if the actors or the people who control the actor of these systems have non-positive human intention, then the agentic AI, from first principles, would have the capacity to destroy us from first principles. And the first principles comes from Ashby's law of requisite variety, that says any system that's more intelligent than another system will dominate that other system. It's not a matter of choice. It's not a matter of human goodwill and us hoping on the intentions of our leaders. Once an agentic AI network gets propagated, and that system does not have human intention and its objective function, that's the end of us. So those are the two. Organization is the best thing to happen to humanity, but it could also be the worst.
Thanks, Chinedu. Yeah, as always, I think this is any conversation I leave with the three of you. I always have more questions than when we started, but that to me is a good thing. Mike, let me toss you the keys.
All right.
You want to drive us home? What is one thing, opportunity and risk?
So I think if mobile phones and that platform is any indication, it will be available to everybody. And Chinedu talked about the math, and Stanley Milgram done the 6 degrees of separation before everybody was connected in a mobile platform and before LinkedIn. So everybody was 6 degrees of separation, right, around the world. And then and then LinkedIn came about, and LinkedIn says, no, we're 3. Agentic AI will change that to 1. Everybody will be separated by 1 degree. And that's the math that he's talking about. And so that changes the economics for everybody. That's the math. The caution in that is, I don't know what that does. And if you and I think that's what Chinedu is talking about. Joseph Heinrich wrote a book called The Secret of Our Success. And in that book, he talks about just the fact that we learned to read and changed humanity forever. What we gave up in order to read was as a part of our brain that allows us to recognize faces. We use that part of our brain in recognizing faces to allow us to recognize symbols and words and understand words, so we made a sacrifice, right? That sacrifice that today says we don't recognize faces near as much as we used to because we compromised that through our ability to read. I don't know what being 1 degree separated from everybody else on the planet does to us. I have no idea. So that's the caution I have, is what does that make us all alike? If it does, it scares me to death, right? Because I think it's our diversity that is our strength.
Well, one thing I am sure of is I'm glad I'm only 1 degree separated from the three of you. So with that, yeah, let's break. I think all of our listeners basically have a lot of stuff to read, a lot of stuff to Google, and so on to begin kind of this understanding around, agentic AI, causal AI, as well as these things of systems thinking and all of both the physics of it, as well as sort of the social structure and the implicit things. And I think one thing that really sort of just stands out in terms of this entire conversation is the critical thinking skills that are required to really understand this. There's just a lot of noise and a lot of other kinds of things in the way. So I think it's one of those things to be liberated, to be able to really think, actually ironically gives me a bit of optimism to being able to solve some of the world's big problems, because there's just too much noise in the way. But if we just reduce that noise, reduce some of those entropies in Chinedu's physics parlance, we're going to get there. So with that, I want to thank the three of you for your knowledge, your wisdom, for your experience, and just being able to kind of share that with everyone. And for me personally, your friendship, it means the world to me. So thank you.
Thank you, Sadiq.
Thanks for having me.